Hello everyone. Today I am going to explain about sets, especially the topics, sets and their representation, types of sets, subsets and universal sets, Venn diagrams and operations on sets, and finally we will end this session with applications of set theory. Without any further delay, let us dive into the topic. What is a set? What is a set? A set is a well-defined collection of objects. Let us understand this. What is this well-defined? Well-defined means you need to be able to decide whether it belongs to a particular group or not. Suppose, let us take one example. A group of rivers belongs to India. So we can tell whether Ganga is belongs to India or not, whether Nile river is belongs to India or not. The Nile river is obviously not belongs to India. Ganga is belongs to India only. So this is what well defined means. See, months of a year. We can tell how many months are there, what are they? All the months. Then days of a week, we can tell. Suppose there is a example like group of tall boys. Group of tall boys in grade 11. So tall means what height you are not taking, you are not mentioning here. So it is not well defined. So you can tell it is not well defined. You see some examples here I mentioned. Group of intelligent students. Intelligence, you are not giving any particular criteria. So it is not well defined. See this one, group of students who scored more than 95. It is well defined. You can tell in a particular subject or overall who got more than 95%, you can group them very easily. But in this case, one person, you can't decide whether he is intelligent or not. Simply just like that, you can't decide. Group of most talented writers in India. How can you tell whether he is talented or not? So we are not able to decide on what basis we need to decide if we wanted to decide also. And see this example, group of odd naturals less than 25. Odd natural numbers less than 25. We can decide -5 is belongs to that or not. 21 belongs to this particular group or not. We can decide very easily. This is what well defined means. Okay. Then coming to the case of definition, you all can see on the screen the basic definition, which is very useful. A well-defined collection of objects is called a set. Sets are usually denoted with the capital alphabets A, B, C, X, Y, Z, and the elements whatever we will take inside them, we will denote with small letters, represented by small letters basically. And suppose there is an element like I told one example like days, number of days in a week, Monday, Tuesday, days in a week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Total 7 days will be there. Set of vowels in English alphabet A, E, I, O, U. You just see A is an element belongs to city. Let me take E. This E belongs to this particular set. That's what they are trying to tell. And that belongs to word, we will represent with this particular symbol. It is called as epsilon. It is called as epsilon. You no need to call this one as epsilon. You can simply tell it is belongs to. Just to see some examples so that you will get clarity. Which of the following are sets? Justify your answer. The collection of all the months of a year beginning with the letter J. You can tell, you can define very easily. January, May, June. You can tell January will start with J. June will start with J. July will start with J. These are the 3 months which will start with letter J. You can decide very easily. So it forms a set. Collection of 10 most talented writers of India. I already we have discussed this. On what basis you are deciding? So they have not given any condition. So you can tell it will not form a set. Here the things are not well defined. Collection of novels written by writer Munshi Premchand. Yes, of course, you can decide whether a novel is written by Munshi Premchand or not. So, collection of all the novels written by Munshi Premchand, we can group them. So, it frames a set. Then, what about this? Collection of most dangerous animals in the world. Of course, on what basis? You are telling that it will be based on that. Okay, let us see. We have a set here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you need to tell whether the element belongs to that or not. 4. 4 we have here. So you will tell 4 belongs to A. You will tell here 4 belongs to A. Minus 4, we don't have any minus negative numbers in the given set. So you can tell minus 4 does not belongs to A. Then what about 12? We have up to 10 only. So 12 also does not belongs to A. 9 belongs to A. Yes, 9 belongs to A. 0. Yes, 0 belongs to A. And minus 2 does not belongs to A. So this is about definition of set. How can you decide whether it frames a set or not? How it is defined or not? Whether it is well defined or not, we have discussed. Let us see. Some examples are sets particularly used in mathematics. Set of natural numbers we will denote with capital N. Set of integers we will mostly denote with Z. Rationals with Q, reals with R, all positive integers with Z plus, all positive rational numbers with Q plus, all positive real numbers with the R plus. Okay. So whenever we are talking about natural numbers, we will take the symbol N. Suppose I am taking a number A, that number is a natural number. I will tell. N means N takes all natural numbers. Okay. Presentation of sets. How you will present is very important. Sets we generally present in two different ways. One is roster form, one is set builder form. What is this roster form? Roster form is nothing but we will list out all elements. Just say some example here. Set of all natural numbers less than 10. I have taken from 1 to 9. Less than 10 means 10 is not included. I am writing all elements. Each and every element based on this condition, I am writing inside the flower brackets or curly brackets, whatever, curly braces. Inside this, we will write all elements. This particular method is known as roster form or tabular form or listing method. That means we will list out all elements, whatever is there in that. Then set of prime numbers 2, 3, 5, 7, and so on. Where it will end, we don't know. Here comes a question. I wanted to represent all rational numbers. All rational numbers. Can we write the all rational numbers in the listed form? It's not possible because rational numbers will not follow any rule like natural numbers or whole numbers or integers. Okay. So we need to have some other method that we'll see. One example we can take here, write the set of all natural numbers x such that 4x plus 9 less than 50. Let us find out x value from this. What is the 4x? 4x is less than 50 minus 9. 4x is less than 50 minus 9 is 41. X is less than 41 divided by 4. Means how much approximately? It is approximately 10 point something. What I want only natural numbers less than this x, less than 10 point something. I want only natural numbers. So I will start forming a set. 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 9 only. I want up to less than, I want up to less than 41 by 4. Okay, like this. First, you need to be solve. You need to be able to solve this particular inequality. Then find out x value. From that, you can find out the solution. Then the other method, set builder form or rule method. Here we will not give any list of elements, but we will tell a condition. You just see one example here that this is a set of vowels A, E, I, O, U. You will not tell about A, E, I, O, U. Particularly, you will tell one condition like X is a vowel in English alphabet. This we will call like X such that these two dots are called as such that X is a vowel in English alphabet. X is a vowel in English alphabet. See one example. Write set A is equals to 14, 21, 28, 35, 42 and so on 98 in set builder form. You should remember always while framing the formula, it is not unique. Different people will frame in a different way. But the result, whatever the result we will get, that is same. Observe this. 14 is a multiple of 7. 21 is a multiple of 7. 28 is a multiple of 7. So you can tell 7 2s 14, 7 3s 21, 7 4s 28 and so on. The last number 7 14s. Okay. You are starting with 2 and you are taking the multiples up to 14. So how can you write the set builder form for this? So first thing you need to find out the pattern. Second thing, you will frame the condition. I'm taking x such that x is some 7n where n belongs to n. I just told the capital N means set of natural numbers. Okay, n is n and the value of n I am taking from 2 to 14. So I will write this one as 1 less than n less than 15. Hope everyone understood. The value of n is in between 1 and 15 and n is a natural number. Okay. This is what the condition and here you need to write and. N is a natural number and n is in between 1 and 15. This is how I will make the condition. Let us see some objective questions based on set builder form, roster form and the basic definition of the set, so you will get more clarity. Which of the following is not a set? Collection of days of a week. Of course, we can frame a set. It is a set only. Collection of prime numbers less than 10. Of course, we can find out very easily. 2, 3, 5, 7. These are collection of prime numbers. So you can tell we can frame a set. Collection of intelligent students in your class. Of course, we cannot frame. I told already that there is no any condition for intelligence. One person may be very intelligent. Based on some criteria only we can decide based on marks or based on his performance in something, based on his achievements, we can decide based on his logic in a particular task. But that conditions they are not giving here, so we can't tell whether he's intelligent or not. So it will not frame a set. Okay, so the correct option is option C. Second question, let us see. B is not an element of set A. We will write that one like this. We have four options. The correct option you can see over here. B does not belongs to A. Third question. Set of natural numbers which divide 42. Set of natural numbers which divide 42 is. Of course, you see here 1 divides 42, 2 divides 42, 3 divides 42, 6 divides 42, 7 divides 42, 14 divides 42, 21 divides 42. So the correct answer is this. Set of all letters in the word better, which is the correct one, correct option in the roster form. I forgot to tell one small nature of set. We will not repeat the elements. We will write only one time. Like this, we have B, we have E, we have T two times, but we will write only one time. We have R. One more E is there, so we no need to repeat it. So our correct answer is BETR, option A. What is the question 5? Set A is equals to X such that X is an odd natural number. Odd natural numbers we will write. What are the odd natural numbers that we can see here? 1, 3, 5, 7. Of course, these are odd natural, but it is ending with 7. 3, 5, 7 and so on. Dot, dot, dot. But 1 is also odd number. At the same time, natural number that is not included. So this is not correct. This is not correct. You just see here 1, 3, 5, 7, dot, 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 and so on. So the correct answer is option B. Some questions. A team of 11 best cricket batsmen of the world. Which of the following are sets? Again, I can tell. I can't tell on what basis you are telling. 11 best crickets, best batsman of the India, of the world. On what basis? So we can't frame a set mostly. Collection of all boys in your class. Yes, we can frame a set over here easily. Let's see one example, one more example. Collection of boys in your class, we can frame a set with this. Next one is collection of all natural numbers less than 100. Yes, of course, we can make a set here. 1, 2, 3 and so on up to 99. Then question number 9. If A is equals to 1, 3, 5, 7, 9, 11, 13, 15, then insert the appropriate symbol belongs to, not belongs to in each of the following. Okay. 1, yes, it is belongs to A. 6 is not belongs to A. 6 is not belongs to A. 9 is belongs to A. And 14 does not belongs to A. Yeah. Question number 10. Write the set they have given. Set builder form. A is equals to X such that X belongs to Z. Z means integers. And X square is less than 20. X square is less than 20. You need to take such kind of numbers where X square is less than 20. X square means square of the number. 5 5 is 25. Of course, it is greater than 20, 4, 4, 16. So I will take from minus 4, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. All these numbers squares are less than 20. You can write this same thing in another way also. 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4. Like this also you can mention the set. Okay. Let us see question number 11. Write x such that x is an integer and minus 3 less than x less than 7. This is less than or equals to. In roster form, I want set builder form. So I'm going to write it. Value of x must and should be in between 3 and minus 3 and 7. Minus 3 is included. So minus 3, I will start with minus 3. I want only integers. Next integer is minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, not 7. 7 is not included because they have given less than only, not less than or equal to. Write set A in set builder form. They have given tabular method and we wanted to write set builder form. 3, 6, 9, 12, 15. These are multiples of 3. Hope you can observe the pattern very easily. 3, 6, 9, 12, 15. These are multiples of 3. So I will write the answer like this. There is a set A, x such that x is natural number and x is natural number and yeah, wait. I forgot to write the condition. X is the such x belongs to 3n where n belongs to n and n is less than how much? N is less than 3 5s 15. I will write 6. So I can frame the set very easily. Let's see one more example. Write the following set in set builder form. A x such that x is equals to, observe the pattern here, 1, 4, 9. 4 is 2 square, 9 is 3 square, 100 is 10 square, 1 is 1 square. So I can write here x is n square where n belongs to n and n is less than 11. N is less than 11. That's it. Hope everyone understood how to convert from set builder form to roster form and roster form to set builder form. Let's see. Second topic, types of sets. What are the basic types of sets we have? First one is empty set. Empty, the meaning itself reveals us one thing, that empty means nothing is there. Okay. A set which does not contain any element. A set which does not contain any element is called as empty set or null set or void set. Remember the names? Empty, null or void. It is denoted with two symbols. This symbol is known as pi, or else you can mention the empty set like this also. See, one example here, x such that x is a natural number less than 1. Of course, we can't see natural numbers less than 1. Natural number starts with 1 only. So that particular set is empty. Example 1, you can see here one example. Which of the following sets are empty? Which of the following sets are empty? Set of all natural numbers divisible by 5. Of course, natural numbers which are divisible by 5, like 5, 10, 15 and so on. So it is not an empty set. Question number 2, set of all even prime numbers. We have such kind of set, like 2. 2 is even prime number, so it is also not empty. Now see this third question, x such that x square minus 2 is equals to 0. Let us solve this. What is this x square minus 2 equals to 0? What you will get? X square is equals to 2 and the value of x is plus or minus root 2. Square will become root. Now observe, we know that root 2 is not a rational number. It is irrational number. What are they asking? They are asking x is a rational number. We want a rational number. We got the result as irrational number. So this particular condition frames empty set. Okay. Question number 4. X such that x is a point common to any two parallel lines. If you take two parallel lines, there will be no common point. There will be no common point for any two parallel lines. So this one also will frame one empty set. Okay. Yes. Let us see another set, another type of set. Singleton set. What is meant by singleton? Singleton is nothing but in the set we will see only one element. Only one element. If no element, it is called empty set. If there is only one element, it is called as singleton set. One example you can see. Second example, A belongs to x such that x plus 8 is equals to 0 and x belongs to z. Let us solve it. X plus 8 equals to 0 and x belongs to z. What is the meaning of this? Z means x is a number which is one integer. If you solve this, what you will get? X is equals to minus 8. That means in the place of x, you can take only one number where you will get 0. So the set will be minus 8. And we know minus 8 belongs to integers. Okay. Which of the following sets are singleton or non-singleton? Let us see. A is equals to x such that modulus x is equals to 7, where x belongs to n. Is it singleton? Yes, let us see. I am going to write the tabular form of this. In the place of x, I can take two numbers. One is minus 7, one is plus 7. You know why? Modulus of minus 7 and modulus of 7, both we will get the same result 7. So it is not singleton. Second question. Set B is like this. X is such that x square plus 2x plus 1 equals to 0, where x belongs to n. Let us solve this. X square plus 2x plus 1. I can write it as x square. Will I get? I think I will not get. One example like x square plus 2x plus 1. X belongs to n. If I solve, what I will get? Let me solve this by using the roots formula. Minus 2 plus or minus under square root b square, 4 minus 4ac, 4 into 4. Okay, divided by 2. Minus 2 plus or minus 4 minus 4, 0 divided by 2, which is nothing but minus 1. What are they expecting here? They are expecting x value belongs to natural numbers. We got plus or minus 1. Minus 1 as the results. So it will not form a singleton, but it forms empty set. It forms minus 1 singleton. X is not belongs to integer, right? It is not integer. Okay, it forms empty set. Question number 3. C is equals to x such that x square is equals to 9, where modulus of x is less than or equals to 3. Observe, x square equals to 9. What is the value of x? It is plus or minus 3. And they are asking to take less than or equals to 3. Of course, you can take the set like this, minus 3 and plus 3. It is not singleton again. We have two elements there. Okay. Let us see next type of set, finite set. What is meant by finite? Which is limited. I mean, we can count. Which is empty or consists a definite number of elements. Empty or consists a definite number of elements. Means, if we are able to count how many elements are there inside the set, it is called as finite set. Just see here, we have 4 elements because it contains a definite number of elements, only 4 elements. The solutions of x square equals to 25. X square equals to 25 and the value of x will be plus or minus 5. How many solutions you are getting? One time plus 5, one time minus 5. We can count how many solutions we will get over here. We will get 2 solutions. Okay. Here comes a new concept called cardinal number. Cardinal number. So you will tell, suppose there is a set A with these elements A, E, I, O, U. N of A is nothing but number of elements in set A. 1, 2, 3, 4, 5. Total 5 elements are there. Like that you will mention. Then what is this infinite set? Infinite number of elements will be there and we can count how many elements are there inside the set. Just see here some example. 1, 4, 9, 16, 25, dot, dot, dot. That means there is no ending for this. So we can't count what is N of A exactly. We can't tell. So this type of sets are known as infinite sets. Next, equivalent sets. Suppose I have 2 sets, set A and set B. Here you can tell N of A is 4. N of B also 4. That particular case you will call set A and set B are equivalent, not equal. Equal and equivalent are different. These are equivalent, means number of elements are same. Okay. Equivalent or not, you need to tell here. We know N of A is 3. N of B is, let me count, 1, 2, 3, 4, 5. N of C is 3. N of D is 1, 2, 3, 4, 5. You can tell N of A is equals to N of C. These two are equivalent. N of B is equals to N of D. These two are equivalent. Equal sets. Just observe, 2 sets are said to be equal if they have the same elements. Same number of elements, equivalent. Same elements, equal. Observe this. From the following sets, select equal sets. 2, 4, 6, 8. Anywhere do we have that numbers? Observe E, set E. Irrespective of order, A is equals to E, we can tell. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you can tell B is equals to D. Here we have minus 2. So it will not be equal with any another set in this given list. Okay. A and E are equal set, B and D are equal sets. Let's see next slide. Some examples, objective questions. The empty set is represented by, empty set we will represent with pi and this. What will happen if you take like this? Inside the set there is an element, it will never be empty. What if you take like this? It is a set with one element, so it is also not empty. So we have option 1 and 3. So the correct option is option A. Identify the null set from the following. First of all, let us try to convert into tabular form. X such that x is a natural number, x is less than 5 and x is greater than 7. X is less than 5 and x is greater than 7. Such kind of combination we wanted to find. We wanted to find. Is it possible? Is it possible to find? Okay, it should satisfy both of these conditions. So it is not possible. Definitely it will make an empty set. Question number 2, you see, y such that y is a point common to any two parallel lines. Of course, already we have discussed this. We can frame empty set with this. So these two are correct. Both options will frame null set. Question 3. The set x such that x square is equals to x and x belongs to n can be expressed in roster form. Okay. You need to take a number and the square of the number also, that number itself you should get. Like if I take a natural number 1 square, I can tell the result also 1. So I will get the set like this. Why I am not taking this? 0 square is 0, of course, but what is the condition we have here? The condition is x belongs to n, means natural numbers. 0 is not natural number. That's why I am not taking this. Okay. Option B is correct. Question 4. Let S be any set and n of S is a natural number. Then the set S is dash y. Here y refers to empty set, infinite set, non-empty and finite set. None of these. None of this. We have 4 options. Let S be a set and n of S is a natural number. What is the meaning of this? That means you are able to define how many elements are there inside the set. What is the correct option? Non-empty finite. Non-empty finite. The set is not empty and at the same time you can count how many elements are there inside the set. Question number 5. Let A is equals to x such that x belongs to z and x square is less than or equals to 4 and b is equals to x such that x belongs to r, x square minus 3x plus 2 equals to 0. Let us solve this and find out the solutions. X square minus 3x plus 2 equals to 0. If you solve by splitting the middle term, x square minus 2x minus x plus 2 equals 0. X is common, x minus 2 minus 1 is common, x minus 2 and x minus 2 is common, will be left with x minus 1. The value of x is 2 or 1. We are getting two solutions, 1 or 2. So the set B will be 1 comma 2 and the set A already they have given. Set A is this minus 2 minus 1 0 1 2 because they are expecting x square value less than 4. Less than 4 means all these values square we can take. Now they are asking, are these two sets same? I mean equal? No, they are not equal. They are not equal, obviously. Yes. A belongs to B? No. A does not belongs to B. This option is also not correct. So we have only one correct option, that is A is not equals to B. Let's see. Third topic, subsets and universal sets. What is meant by subset? Observe the last example, 1 and 2. I told A is not equals to B, but these two elements I can see over here. Observe clearly. The two elements I can see over here. Whatever the elements is there in the B, all those two elements are there in the A. That case, we will get subset concept. Let A and B are two sets. If every element of A is an element of B, if every element of A is an element of B, then A is called a subset of B. Observe, they have given some more examples here. 2, 4, 6, 8, dot, 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 1, 2, 3, 4, 5, dot, dot, and so on. In the case, whatever the elements are there in this, all those elements you can see in set B. Set B is bigger than set A, we can tell. Because set A is only even numbers, even natural numbers. Set B is natural numbers, set of natural numbers. So you can tell all elements we can see in set B. So A is subset to B. The symbol you will call as subset. The symbol is subset. Okay. You see, every set is a subset to itself. I have a set 1, 2. I'm telling that another set I have, it is also 1, 2. I can tell all the elements of this particular set are there in this. So you can tell this set is subset to this. It is A, some P you take. P is subset to A and A is subset to P. That's what? Empty set is subset of every set. If you want proof, let us have a small discussion over here. Empty set is not having any element. You take any another set. Let me take set A as this 1, 2. Now I wanted to prove this is subset to A. How I will prove? Just understand this concept like this. It is not having any element. If not, the element, whether the element is belongs to a set or not, we will learn. What is our condition? All the elements must and should be there in the another set. That particular set is known as subset to another set. But here none of the element is there in this set. So definitely it belongs to the particular set. You no need to prove because there is no elements in that. So obviously it will be subset. Just remember, empty set is subset for every set. Yes, very important concept, very important formula is this particular formula, that number of subsets, how many subsets you can form for a particular set. Suppose I have a set like this 1, 2, 3. For this I can frame subsets like it is a subset, it is a subset, it is a subset, it is a subset. 1, 3 is another subset, 2, 3 is another subset, 1, 2, 3 is another subset. Of course, one more subset is 5. Total how many subsets I am able to generate here? 1, 2, 3, 4, 5, 6, 7, and 8. Total 8 subsets. There is a relation between the number of elements and this 8. That condition is 2 power n. N is the number of elements. 2 power 3 is nothing but 8. Okay. This is clear. A is subset to B and B is subset to C. So you can tell automatically A is subset to C. If A is equals to B, A is subset to B and B is subset to A. The basic formulas you can remember here. These are the important points which you need to remember coming to the case of subset. And the very important point is this: how many subsets you can frame, how many proper sets you can. What is this proper set? What is this proper subset? You don't need to consider this. Other than that particular, remaining all are called the proper subsets. Okay. So how many proper sets we can see for this particular example? It is 8 minus 1, nothing but 7. Universal set. Understand the concept like this. I have 3 sets A, B, C. I can see all the elements in this. Then this particular set is known as universal set. Superset for all the numbers, the sets with the numbers. Okay. Suppose you are taking animals. All animals will come into a single set. That particular set is known as universal set. Okay. If you are talking about rivers, all the rivers come into that particular set. That particular set is known as universal set of rivers. Okay. That particular category, basically everything will be there in that. And the symbol for universal set is this U or mu. A universal set. There is not. Some conditions we have to see, particularly open interval, closed interval. These are very important while finding the domain and codomain. Means what is the input and what is the output for a function. Okay, let us see this. What is the meaning of this? A comma B on real numbers, on real number line. Suppose you are telling 2 comma 3. What is the meaning of this? Between 2 and 3, whatever the real numbers will come, those all solutions we will consider. Okay. Open interval. This is open interval. We are not considering the 2 and 3. Between them, whatever the number we get, all those numbers we will consider. Then what is closed interval? Closed A comma B is nothing but we will consider all the numbers between 2 and 3, including 2 and 3. Including these two numbers also included. But in this case, these two are not included. Okay. Half open. That one side closed interval, one side open intervals. Like this also you can take. What is the meaning? A is included, but B is not included. A is included, B is not included. Let us see some examples so we can understand very easily that. Write the subsets of R as intervals. Also find the length of interval and represent on the number line. X is such that X belongs to R. Okay. X is set of all real numbers. Minus 12 less than X less than or equals to minus 10. We wanted to write the solution here. Okay, I will write X value must and should be less than, mean greater than minus 12. So minus 12 also included here and minus 10 also included here. So whatever the numbers are there between minus 12 and minus 10, all the values we can take in the place of X, including minus 10 and minus 12 and minus 10. Then what is the solution for this? X value must and should be in between minus 4 and 6. Okay. But 4 is not included here. So I will take open interval, open brace, and 6 is included. That's why square bracket here. What is the solution for this? Is minus 12 less than X. So 12 is not included. 10 also not in, minus 10 also not included. Minus 12 is not included, minus 10 is not included. Between them, whatever we have, all those numbers is our input. 0 less than or equals to X less than 7. So less than or equals to is there. So I will consider 0 also and 7. Then what do you tell about this? 3, 4. Yes. Both values are included. That's why they kept here less than or equals to. Then Venn diagrams. What is this Venn diagram? The same set, whatever you are telling now, A is A, E, I, O, U. All these elements we will mention inside a circle. Okay. These are known as Venn diagrams. The remaining alphabets in set B. Okay. These are known as Venn diagrams. In Venn diagrams, universal set is represented by rectangular, of course, a rectangular box. Okay. Subsets are represented by circles. It is not in circle shape, of course. You can take ovals or circle shape. Point within the circle, universal set, set A, set B. Set A is having 1, 2, 3, 4, 5, up to 10. Universal set is 1, 2, 3, 4, 5, up to 10. And set A is 1, 2, 3. All those three elements are there inside the circle. Remaining elements are there outside the circle. In operations on set, very important. We reach very important concept. First one is union of sets. What is meant by union? Combined. I have two sets, set A and set B, with set A with 2 elements, set B with 3 elements. I am making a new set combining all those elements. 2, 3, 4, 5. I already told we will not repeat the elements, we will write only one time. Let us see some examples so we can understand. I have set A like this, A, E, I, O, U. And set B like this, A, C, D. I want A union B. A is there, E, I, A, E, I, O, U. A already I have written. C I need to write. D I need to write. This is A union B. Then what do you tell about this? Set A is 1, 3, 5. Set B is 2, 4, 6. I will write A union B like 1, 2, 3, 4, 5, 6. Okay. X is a natural number less than 1, 1 less than x less than or equals to 5. So the set will be like this. 2, 3, 4, 5. This is set A. And set B, x is a natural number such that 5 less than x less than or equals to 10. The another set is 6, 7, 8, 9, 10 is also included because they gave less than or equals to 10. Combination of these two sets, A union B, I will write here A union B, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is A union B. Union means combination of both without repetition. Loss of union. A union pi is A. If you add, suppose I have A with 1 comma 2 and pi, we know that pi is nothing but no element will be there. If you combine them also, A union pi means A only we will get. Universal set, if you take union with any set, universal set only we will get because it is containing all the elements. A union A is again A. A union B and B union A, they are equal, they follows commutative law. A union B union C is equals to A union B union C. Yes. They have given a name for that. Identity, universal, idempotent, commutative, associate. Remember this? Idempotent. A union A is A. Intersection of sets. This time what they'll tell that what is meant by intersection. We will take only common elements. Just see only common part is shaded. I have set A 2, 3, 4, 5, 1, 3, 6, 4. In these two, we have two elements common, 3 and 4. Those two elements only we will write in the case of intersection. Okay, let us see some example. I have set A like this 1, 3, 5, 7, 9 and set B like this 2, 3, 6, 8, 9. Mark the common elements. We have 3 in both sets. We have 9 in both sets. Any another element? No. So A intersection B is 3 comma 9. Okay. Second example. A we have like E, F, G and B we have like pi. A intersection B. Are we getting any common element? Yes. We will get pi. There is no common element. Then the third example. X such that X is equals to 3n. X such that X is equals to 4n. And n belongs to Z. 3n, 4n. I want only common. Let us write the set A. Set A is 3, 3 to 6. Of course, negative values also will come. Then how to represent that we'll see. Okay. I'm writing only sum. plus or minus 3, plus or minus 6, 3 3 is 9, and so on it will continue. Set B we will have like this, plus or minus 4, plus or minus 8, plus or minus 12, and so on. See, we are able to observe one common element which is plus or minus 12. Then what is A intersection B? Plus or minus 12. Next, what is the next number? It will be the multiple of 12. Plus or minus 24. Okay, and so on. Hope everyone understood this. How to find out intersection. Laws of intersection, you can see. Then some distributive laws. A intersection B union C is equals to A intersection B union A intersection C. A union B intersection C. All those you need to remember. Difference of sets. What is the difference? Just take some example always, it will be helpful for us. I have two sets, set X, set Y. Difference of sets you need to understand. If I am writing X minus Y, X minus Y, what is the meaning of that? I want the elements only from A, only from X. The definition you can see. X belongs to A, but X does not belongs to B. That means here the element whatever you are taking, it must and should belongs to the first set of the given arrangement. Okay, such kind of to find out such kind of elements, what we will do? F, B, D, G, H, K. Are we able to remove the F, remove the B, remove the D? G, H, K are not there. So the leftover elements in the first set we will write A and C. These two elements belongs to X alone. Remaining BDF belongs to both. That's why I'm not writing. So X minus Y is A comma C. Then what do you tell about A minus B? Cancel this, remove the 2, 4, 6. If there is 2 is there, 4 is there, 6 is not there. So A minus B will be 1 comma 5. 1 comma 5. 1 and 5 belongs to A alone, not to the B. That's why it is difference of sets. You can see Venn diagrams also. This particular part is A minus B. That means the elements which belongs to A only. But this common section part belongs for both A and B. This is B minus A. The elements which belongs to only for B, or the place which belongs to only for B. And this is for the place where it belongs to both sets, set A and set B. Symmetric difference of two sets. The symmetric difference we will notate with delta. A delta B. How you will define? A minus B union B minus A. That means set of all elements which belongs to A alone, set of all elements which belongs to B alone. That means other than the common elements for the both sets. Okay. Yes. You have set A like this 1, 3, 5, 6, 7. Set B 3, 7, 8, 9. Then A delta B you wanted to find out. A delta B. Remove the common elements. We have 3. Any another element? No. 7, 8, 9 is 7 is there. Yeah. 7 also you can remove here. And we will be left with 1, 5, 6, 8, 9. This is A delta B and the name is symmetrical difference. The symbol is A delta B. We can write in another way also, like A delta B is nothing but A union B minus A intersection B. Like this, you take all elements from that, remove the common elements, you will get A delta B. Disjoint sets. Disjoint means there is no any connection between them. That means there is no any common elements between them. You just observe set A is not mixing with set B. This type of sets are known as disjoint sets. And A intersection B always pi we will get for disjoint sets. Union, intersection, minus symmetrical difference we have seen. Then what is the complement of set? Observe the example, so you will get the basic idea. Definition is there and the notation is there. I have set A 2, 4 and universal set like this. Then A complement is U minus A. Universal set minus that particular set. Remove 2 and 4. You will get 1, 3, 5, 6. This is A complement. Okay. You can see the Venn diagram. Other than the A, remaining all elements is known as, other than the A, remaining all elements is known as A complement. Okay. Some properties of complement set, A dash whole dash or A complement whole complement. This is known as A dash or A complement. A dash whole dash is A. Okay. A union A dash is U. A intersection A dash is pi. Pi dash is U. U dash is pi. A union B whole dash is U dash minus A union B. Remember, all these properties are very important. Some questions, objective questions. Most of the relationships between sets can be represented by means of diagram, and the diagrams are known as Venn diagrams. Okay. Which of the following represent the union of two sets? Union of two sets. X such that X belongs to A, we have only one. X such that X belongs to B. X such that X belongs to A or B. This one. Union of sets. I am taking an element. We know that A union B means whatever the space we have, entire space. It may be belongs to A, it may be belongs to B. I have A, I have B, and which one is true I wanted to find out. A intersection B is A. Definitely not correct because set A is bigger than set B. A intersection B is not subset of B. Okay, let me find out 2, 3, 5, 7. 2, 3, 5, 7. Of course, it is subset, so this is not the correct option. They are asking which is true. A intersection B is B. Yes, this is the correct. The shaded portion representing in the Venn diagram the common part of the both, which is nothing but A intersection B. We have 4 options. A union B is not correct. A intersection B is the correct option. Okay. Let us see the diagram. If you want A union B means this is A union B. A intersection B means take 2 circles, take the common part, that is A intersection B. What is A minus B? Only I have 2 sets, set A alone, set A alone, but not B. This is A minus B. What is B minus A? You can take for a while, this is A, B, and this will be set B minus A, like that. And there is a last topic, application of set theory. About application of set theory, we will discuss in the next session because that is very important. The video is already lengthy. If there is any doubt regarding the basic introduction of set theory, mention in the comment section and we will discuss it later. Thank you so much.